So here we are, and there's a quiz coming up on the 17th, right? That's, today would be the 15th, is that right?
Yeah.
All right, so that's on Wednesday. And so assignment 1 was practice for taking the quiz. So what I want to do today is just focus on that assignment and go over the kind of reasoning and problem solving that you need to practice in order to do well on quiz 1. Actually, I think we let's go through this again. All right, let's go and we'll just go through each of the problems one after another. So what does this output to the console, this bit of code right here? So when we look at this, you know, I see there's a loop here. I won't look at any other details. And then I see that there's a line here. So it's really, in a sense, two statements. The first statement is defining an integer variable I and initializing it to 0. That's a complete description of that statement. The second statement is a while statement. And it's also called a compound statement because the statement itself contains substatements. So it contains these two substatements here. Each statement is terminated by a semicolon. But of course, the loop itself, that semicolon is not needed here. If we put it there, it would be okay, but that's not needed. So this ends the while statement. But inside the while statement are these substatements. They're conditioned on the loop condition. So as long as the loop condition is true, the statements, the substatements in the while statement will run. We're going to repeatedly run the substatements in the while statement as long as the loop condition is true. So let's go back. We create a variable I, set it to 0. And then we check the loop condition. I, which is 0, is less than 7, so the loop condition is true. That means we execute the body of the loop. And so here it says print something, but we don't. The something is the result of a calculation. So there's two operations. This means multiply 2 by I. This says output what's on the right into what's on the left. C out, and C out will represent the what's called the standard output stream, which by default is the console window. So you see two operations there, but be careful here. You can't do it all at once. You got to break it down into steps. The first step is to perform the multiplication. That has higher precedence than the output operator. So we just look at the 2 and the I, multiply those together. Well, I is 0. And so 2 times 0 is 0. And that result, that's the right-hand side of that output operator. We'll send that into the standard output stream. So that ends up printing 0. And so that statement is now done. And then we come to this statement and we increment I. I was 0, so now I is 1. And I'm just going to keep a little note of what I is right here. I is originally 0, but then when we run this statement here, I will get incremented. Incrementing means adding 1. And by the way, this and this have the same effect. This is called a postfix or post increment. And because the I doesn't appear in any larger statement, these two expressions are equivalent. Now, we'll talk more about that later. I just wanted to remind you about it right now. All right, so we just executed the body of the loop once, and we hit the bottom of the loop. When we hit the bottom of a while loop, we simply return to the loop condition and evaluate the loop condition again. As long as the loop condition is true, we're going to execute the body of the loop. 1 is less than 7. I is 1. 1 is less than 7. And so we're going to see out something. What is something? Something is 2 times 1. We're going to see out 2. To be precise, we didn't output a blank yet. We didn't put a we didn't output a a blank character. So all the numbers will appear kind of squeezed together. This is what it's really going to output. But on the quiz, I don't care if you put a space in there. That's okay for me. All right. And so what I'm showing you is equivalent to this. So after printing the 2, let's print a space. But I wanted to make it easier. I just want you to understand and work through this problem of reading a loop and evaluating the loop without caring about this particular detail. So I'm just going to put a space in there because that's likely what you'll put on the quiz. So we just printed 2 times 1, which is 2. And then we increment I. So we have a record of I here. So I now goes to 2. Now I hit the bottom of the loop, so we return and evaluate the loop condition. And I is now 2, which is less than 7. So now we print 4. 2 times 2 is 4. We output 4. And we can see the pattern there. Obviously, I is going up 1 at a time, but we're printing out 2 times I. Right? So it's going to be like this, obviously, right? So it's going to go. It's going to keep going until the loop condition is false. So when I hit 6, we're okay. But when I hit 7, the loop condition is false, so we don't execute the body of the loop. So the last value for I that runs the value of the loop is 6. However, I does hit 7. It's just that when I hit 7, we don't execute the body of the loop anymore. 7 is not less than 7. So I know that I is going to hit 6, so we're going to end up printing 12. And then when I is 6, we're going to end up printing 12 right here after having printed 10, 8, 6, and so on. And then when we increment I will hit 7, we'll exit the loop. So we're never going to print anything past 12. There we go. So when I is 6, we print 12 here. We increment I becomes 7. And then we check the loop condition. The loop condition is now false. 7 less than 7. That's a false statement. The loop condition is now false. 7 less than 7. That's a false statement. And so we skip over this, and we continue executing after the while loop. But we don't know what's there. I didn't give any more code, so that's enough. Any questions on this? Okay. Rewrite the code in Figure 2 so that it uses a while loop rather than a for loop to accomplish the same output. So we have a while loop, which is going to have a loop condition, and then we'll have a body of statements. And you can see that in the for loop, we have these three sections. The loop condition is in the middle. And the end of loop operation is here, which is to increment I. And inside the body of the loop, we output 2 times I. So it's the same problem as problem number 1. And then we have initialization. So initialization is in the first section of this for loop. This is initialization. It's run once. This is the loop condition. And this is the end of loop operation. And these are the, in addition to the end of loop operation, this is the one and only statement that executes. So that's what that looks like. How many times does the body of the for loop run in the above code? Let's look at that. How many times does the body of the for loop run? So this is the body. The body is in between these two braces. This is the opening brace. This is the closing brace. For each, so let's see, how many times? So basically we're going to print what's ever in I, we're going to print it for as many times as we execute the body of the loop. So let's analyze this. We start by declaring a variable k and initializing it to 100. And then k is used in the loop condition. As long as I is less than k, we'll execute the body of the loop. And we'll increment I at the end of the loop. We'll do those two things. So the while loop is simpler. The while loop is check the loop condition, execute the body of the loop. Check the loop condition, execute the body of the loop. Do it like that. But the for loop is a little bit more complicated. First do an initialization, then check the loop condition and execute the body of the loop. Check the loop condition, execute. It doesn't have this end of loop operation, and it doesn't have any initialization built into it either. It just has a loop. It's just a bare loop condition. So the while loop, I think, is easier to think about. But here we have a for loop. Here's the loop condition, I less than k. Now, look at k. K is initialized to 100 here. And the code in the body of the loop does not alter k. So k remains 100 throughout the execution of the loop. So you can think of that k as a constant. And I here is incremented at the bottom of the loop because of the end of loop operation here in the third section of the for loop. So I starts at 0, and then it's incremented until it hits 100. When it hits 100, the body of the loop doesn't run. So it starts at 0, runs the loop, goes to 1, runs the loop, goes to 2, runs the loop, goes to 99 and runs the loop. So it starts at 0 and goes to 99. For each of those values, 0, 1, 2, 3, 4, 99, for each of those values it runs the loop. And then when I is incremented and hits 100, the loop condition is now false. So we're done. So the body of the loop executes for values of I equaling 0 to 99. How many values are there? 100, because we start at 0. We started at 1 to 99, well, that's 99 values. But 0 to 99 is going to give us 100. what does this code output to the console? What does this output to the console? All right, there's a loop here, and it's a while loop. There's some initialization here. I is created, set to 11. There's a while loop that's conditioned on I. Inside the body of the loop, we change the value of I. We reassign I to I plus 3. We add 3 to I over and over again. So that means I is increasing by 3. It starts at 11. It goes to 14, goes to 17, goes to 20, and so on. And as soon as I hits 100 or above, it either hits 100 or 101 or 102 or any number above 99, then the loop condition becomes false. So I is increasing. And as soon as if it hits 99, we're going to execute the loop. And that would become 102. But we don't know if it hits 99 because we start at 11 and we're adding 3. So we had some number of 3s. And look, in the loop, we don't print anything inside the loop. You see the C out here, this is after the loop finishes. When the loop terminates, we do the next statement, which is C out I. So we're only going to print one number. That's a little confusing for some people. We've got to pay attention to the opening and closing braces. They enclose the statements that get repeated. And then anything following the closing brace is the statement that is executed after the loop terminates. So I takes on the value 11, and then it goes to 14. It goes to 11 plus 3, and then it goes to 11 plus 3 plus 3, then 11 plus 3 plus 3 plus 3, right? So it looks like this. It's 11, and then it becomes 14, then it becomes 17, then it becomes a 20, and so on. And the general form is it's 11 plus some number of executions times 3. So we're going to add, we don't know, some unknown number of 3s we're going to add to 11. So we could kind of make a rough guess here and say, well, what's 11 plus n times 3, you know, approximately equal to 99. So we solve for 3. I mean, sorry, solve for n. Can't solve for 3. 3 is 3. And so that's the expression n times 3, you know, equals, I'll put double equals there for approximate. And that'll be, what, 99 minus 11, which is 88. So let's take n equal 88 divided by 3. What do we get for that? 29? Okay. So that's just a guess. I'm just trying to calculate an n that's going to give us something close to 99. All right, so 11 plus 29 times 3 gives us what? 87? 11 plus 87? Did I get that right? And that's going to be 98. Okay, good. So, you know, I will hit this value. We will execute the loop 29 times, in order to add 3 to I 29 times. When we add 29 threes, that's the same, that's adding 87, right? Remember, I started at 11. And so I will hit 98. Now, when I hits 98, the loop condition is true. That means we're going to add 3 more to I. So that means I becomes 101. So when I is 98, we're going to add 3, we get 101, then we're going to evaluate the loop condition 101 less than or equal to 99. That's false. That's a false statement, and that means the loop is terminated. I is 101, and then we see out I, but I is 101, so we see out 101. I think that's the hardest one in the assignment. Okay? I mean, you could actually do it one at a time, but you know, I might give you a big number on the quiz. Maybe I'll give you this. This is harder. You can't do it one at a time, so you got to do some calculation. You have to guess at how many times a loop runs, get a value that's close to 999, and then figure it out from there. Okay. Any questions? Okay, when this code runs, what does it output to the console? Well, there's 2 things that I want you to learn here, and maybe 3 things. One thing is the order of execution. This is an operation. It's an output operation. This is a division operation. It's an output operation. This is a string. This is another operation, an output operation. This is a division operation. So we got, and the operations are performed one after another. They're not all done at the same time. So we have to figure out which one is done first and do it. And so these output operators have the lowest precedence. And so the division operator beats out the output operator. We're going to do the division operator first. That means we're going to take 1 divided by 2 here. And it's going to end up being, what's 1 divided by 2? 0. Everybody clear about that? Why is 1 divided by 2? Well, this here is called integer division because the numerator and the denominator are both integers. So the compiler says, oh, you want integer division. Confusingly, this slash is floating point division because the denominator is a floating point expression. There's a decimal point in there. The compiler says, oh, you want floating point division. You know, in an ideal world, if, you know, we knew this was going to happen when we designed keyboards when typewriters were first built, maybe we would have done something like this to, you know, differentiate. So these are 2 different operations. This operation here is, I mean, it's similar, it's related in concept, but it's a different operation than this. You get a different result. It's the same symbol, though, so that's different meaning. Call someone bad, or you call someone bad, you know, it's the same symbol. It has 2 different meanings.
And when it rounded up to 1 since it's 25?
It does not round, it truncates. If the result is 0.999999, that will be, oh, see, 0. That will be 0. It truncates. It drops what's behind the decimal point. How do you round? Add 0.5. So a rounding operation would look like this. Wait a minute, that's not right. Because this is 0. Sorry, this is not working. This is not correct. Sorry, that is not correct. Totally incorrect there. This would be, I'm not going to get into it now. Actually, it's one of the lab exercises. I'll talk about it in that context. I don't want to get into a confusing line of thought, in which I'll need to clarify and work out. All right, so 1 divided by 2 is a half, 0.5. We'll drop everything to the right of the decimal point. We just get 0. And then we get this comma, there's a space. This is called a string literal. It's just what it is. It doesn't represent anything, then it's what it is. It's an expression that represents a comma followed by a blank. I see. The variable, like if you had x, that's not a literal, that's a variable. So a literal is different than a variable. And then, so we're delaying these operations. So now we have 1 divided by 2.0. So you can think of it as, let's do one pass through here. And in the first pass, we'll do this operation first. And then in the second pass, we'll do the next division. Those have the higher precedence. I'm not sure the compiler actually does it in that sequence. It doesn't have to do it that way. So we could output this, and then we could output this, and then we could do this division, and then output the result. So it's doesn't necessarily happen this way in machine instructions, but it might. And anyway, it has the same result. Let's do the, I believe, although I can't say with absolute certainty, that this is the next instruction that runs, although there's an alternative sequence that gives you the same result in this case. All right, so when we take 1 divided by 2, we get a floating point value, which is 0.5 or 0.5, whatever. So that's integer that's a floating point division. Everybody okay with that? All right, now we've done the 2 division operations. Now we have 3 remaining operations to do. And these are the output operations. And with the default order is left to right. Almost all operations, when there's a tie in precedence, you go left to right. And so the first output operator you're going to run is this one. That means you're going to output, and what it does actually is it does this. It outputs, it sends 0 to the output stream, and then this itself is an expression, cout arrow, angle 0. That's an expression which evaluates to a value. It evaluates to something. It evaluates to cout itself. That's why when this thing is done, the result looks like this. Oh, that didn't work. The result looks like this. And then we have a similar situation. We have the output operator that's the leftmost is going to run first, be evaluated first. You can think of evaluation as taking an expression and replacing it by what it evaluates to, what it becomes. So cout less than, quote, comma, space, or not comma, quote, comma, space, quote. That prints comma, space, and then the whole expression evaluates the cout. Finally, this whole thing runs as well. That also evaluates the cout, but you know that doesn't do anything. That's sort of discarded at that point. So let's go back and look at when this evaluates, we print the 0. Then when this operator evaluates, we print a comma and a space. And then finally we have this final execution of the output operator, so we get 0.5. That would be the answer. All right, let's take a look at this one. You can take what you're learning in this language, C++, and apply it to other languages. No problem. There's some variations, there's some changes, but it's essential and it's very similar. For instance, the use of this postfix and prefix increment operators is the same across all languages. There's no language that interprets that any differently. They all have the same meaning across all. The same with asterisk. It's always, well, no, maybe there's some variation there, a little bit. Okay. What does this print? Oh, we have I, we initialize it to 2. Let's do that. Let's take I and set it to 2. And then we create K, and we set it to the result of this expression, I++ times 2. Now, this is a post increment. That means we're going to use I in the expression in which it appears, and then after we use I in that expression, then we will increment I. So let's use I. I is 2, so we do 2 times 2, which is 4. And then 4 is assigned to K. And then it gets incremented to 3. I'm not sure, but it could be a little different than that, but it gives you the same answer. And let me give you the variation, and I just don't know which one it is. It's probably the second one that I'm going to explain. When we come to assign a value to K, we need to evaluate this expression. And this post increment is inside the expression, so its execution is delayed until the expression is evaluated. So I, which is 2, is multiplied by 2. That gives the expression becomes 4. But we don't assign the 4 to K. We carry out the increment on I first. And now we assign 4 to K. I think that's the way it happens. But I actually haven't dug into this. I've never seen a situation where I needed to distinguish between those two possibilities. It gives you this, in this example, it gives you the same result. And I don't know if I can create an example that, that would force us to make the distinction. And I don't want to get into that, so I'm just going to, you know, this process that we've applied in either way is going to give us the same result in all the cases that we'll look at in this class. You see this plus plus? See, I is initially 2. And when the plus plus, at some point, the plus plus operator is going to run. It's going to increment I. At some point, I is going to hit 3. The question is, at what point? The point that I is incremented is after the value in I is used to process this multiplication. We're going to take I, which is 2. We're not going to increment it yet. We're going to hold off. We're going to multiply by 2 and get a 4 out of there. And then, now that we've used I, we're going to modify I. We're going to increment it. Does that help? Yeah.
What was the option? Like, was I first and then you multiply I first?
You want to see? Let's do that. It's a great suggestion. What happened if we had plus plus I instead? That's a very good idea. Thank you for suggesting that. So we've got I is initialized to 2, and K is going to be, here's the problem. Want to know, you know, this assignment, what gets assigned to K? Right? What does K become as a result of this assignment? So plus plus I, this says, hey, increment me right away. I know I'm in an expression. I'm in a larger expression. You know, whatever I am, I'm going to multiply by 2. But before I do that, I'm going to increment I. Do I right away. So I is going to become 3. And the result now that I is now 3. And now so 3 times 2 is 6. And 6 is assigned to K through this assignment operator. I is the same. Look, up here I becomes 3. Because we only increment it once. We just delayed the increment. Here, I, in the same way, is only incremented once. But we do the increment immediately before we use I in the expression in which it appears. So when we increment I early, we're going to get a bigger number when we do the multiplication. So what do we output here? Let's go back to this situation where we have I, after this second statement executes, I will be 3 and K will be 4. Okay, and we'll do this one as well. This doesn't, this is just for practice, that second one. After the second statement executes, I will be 3, K will be 4, and then we're going to do the next statement. But the next statement is comprised of multiple operations, so we have to decide which operation to do first. Well, this output operator has the lowest precedence. So we're going to need to evaluate the right-hand side of that operator, which is this, and get a number, and then print that number. All right, so the problem comes down to evaluating this expression. We've got a plus, that has very low precedence. We'll do that last. And this is times, it's got higher precedence than addition. And pre-increment That has the highest precedence of all. Let's do that right away. Just get it done. So this says, in this expression, we're going to increment I. Now it's a pre-increment. There's nothing tricky about it. That's just done right away immediately. So I will now become 4. And then I becomes 4. Now we're going to do the multiplication. X has the next highest precedence. So 4 times 2 is 8. So this expression here, this sub-expression evaluates to 8. And the side effect is that I became 4. So we take 8 and we add what's in K. So that becomes 12. And that, so the whole expression is evaluates to 12. And that's the right-hand side to this output operator. And we end up displaying or printing 12. And down here, you know, it's similar down here, but it's the same thing, right? Except that the K is now 6. So we increment I, that becomes 4 times 2 is 8, and 8 plus 6 is 14. So we print the 14. What's that? Okay. You know, you can invent a lot of these problems for yourselves and just sit there and just make an expression. And then try to figure it out mentally and write down your guess. Or maybe it's better than a guess. Write down the result of your analysis, and then actually run the thing, and let's see if you get it right or not. And then try different expressions. You can push yourself, and really, you can master this. It's very easy to master. Just give yourself 15 minutes of playing with it. Yeah, question. That's a good question. And I don't know. I think that, I don't know. Let's do that experiment. But let's do the other problems first. And we're going to come back. That's a very good question. And let's do that experiment together. But let's do the other problems first, and we'll come back to that. And how could we figure that out? Look at this. Watch this. If we did this, actually, we can do it now. Let's do it now. Maybe we won't do it now, because it's 12:55. How about if we did that? That'll help us. That'll give us the understanding, right? So, do we increment I before we do that addition, or do we increment I after we execute that addition? That's the question, right? So we'll get one of two different answers. We can simplify this. Let's set I to 2. And this is, say, output 1. possibility I'll do. Possibility 1. Oh, I'm sorry. This should be the post increment. I'm sorry about that. This is the that one right there, right? That's the one I'm concerned with. So this is a delayed increment. So does the increment before the addition? Or is it after the addition? So if it's before the addition, then it's I plus plus is, so 2 times 2 is 4, and then we increment I to 3, and we get 7. And if it's after the addition, then it's 2 times 2, which is 4, plus 2, which is 6. I gotta have a guess, right? This is what I think it is. No, I'm sorry. I think it's this one. We gotta do this, right? Because you're printing it, huh?
I said it would make more sense if it was 6 because you're printing that, then you're changing it. So like you're not after the addition, you're not done until you're semicolon end.
Yeah, maybe. Does the increment happen even after the output operator? Huh? Did you run it?
No, I want you to run it.
Oh, yeah.
We got 2 minutes.
We got 2 minutes? No, it's 1:15, right? 1:15.
I have.
Okay. Oh, you have 2 minutes. Oh, you made me panic there for a minute. Okay. Okay, here it is. Look at this. I'm indenting my code. I didn't have to do that, right? I could have just a quick sloppy example. But I'm going to indent my code anyway because I'm a disciplined person. And I want to remind you that you need to indent your code. All right. So it's going to print 6 or 7. What's it going to print? Anyone want to make a bet? I'll go 5 to 1 on $1. Wait a minute. That's probably, I think that's illegal, right? So let's cancel the bet. Cancel the bet. I'm not breaking the law in lecture. Okay.
Edit that part from your YouTube video.
You know what? Let me put that new line in there, but it looks like it is 6 in fact. Here it is. 6. We got it. Okay. All right, let's carry on. All right, write a program that computes the sum of integers 0 through n where n is an integer entered by the user. So we're gonna print a sum at the end of the day. And we need to, the sum is going to be like this. So when I add the values together, 0 through n, let's check that again. Write a program that computes the sum of integers 0 through n, where n is an integer entered by the user. You can do this if you can do this, but once again, this is optional. I'm looking more for the logic, not for the this input. So that's n. So the user is going to enter in an n. Once again, you don't need to write those for my purposes. And but so once you have an n, how do you add them together? So we're going to have a loop. The easiest loop to do is to use a for loop. We'll need to declare a sum variable, set it to 0. You need to initialize sum to 0. C++ does not, by default, initialize variables that are declared. So we need to be specific about the initialization. Yeah, good. Thank you. That's not quite it. That doesn't get the n there, does it? So we'll need to make that less than or equal to. Thank you. And just showing you some new notation there. Plus equals I, right? You know what that does? Plus equals. That's another common syntax. You find it in all modern programming languages. That's the same as saying sum equals sum plus I. That's the same thing. These two expressions result in the same result. That's it. Does anybody want to propose an alternative solution? Any math majors in here? Well, this is what I wanted you to do. The purpose of the exercise is to learn how to write loops, but there is an expression that calculates this number directly. Does anyone know what it is? I think this is it. Divided by, is it 2? Is that right? Isn't that the sum of values 1 through n? All right, let's suppose n were to be 4, right? So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, right? So 1 plus 2 plus 3 plus 4 is 10. So if n is 4, it's 4 times 5, which is 20, divided by 2 is 10. I think I got it. But, so this would be the clever solution, if you knew that. But I want you to practice the looping. Write a C++ program that prints every number between 330 and 550, inclusive. All right, here's another loop. 330 to 550, inclusive. We can use a while loop or a for loop. 330 to 550, inclusive, right? Inclusive means include 330 and include 550, right? That's what inclusive means. Exclusive means it would start at 331 and end at 549. Let's start at 330. Let's continue until we hit 550. Well, let's continue until we hit 551. Then we'll stop at 551. There it is. You know, that's okay. And if you wanted to be neat about it, you know, you could do this. That's optional. Okay, that's optional. I want you to understand how to, you know, solve a word problem in a sense. You know, print numbers, something that needs repetition, something that's going to need a loop to solve. That's what I want you to grapple with and grasp at this point.
If it stops on 550, would that be essentially too?
If it stops where?
On 550, at the beginning, increment?
Oh, if you left this, okay? That answer, okay?
No, not like that.
Oh, not that way? Which way?
Just like that. Let's be 10%.
Wait, I'm not clear. Say it again.
You know what? Never mind. I see. The difference is like you use a while loop.
Yeah, you could use a while loop too. Do you want to see it as a while loop?
It's the same thing, just written a little different.
Yeah, you break it out. Just really quickly. As a while loop. You got the initialization. You got the loop condition. And you have the end of loop operation. You just have to edit the code a little bit. That's it right there. There's the while loop. So there, while loops and for loops are interchangeable. Yeah.
For the while loops and for loops, are those always going to be the format for them?
Yeah, there's no variation on the format that I'm aware of. I mean, you could see things like this. Like, here's this for loop. I mean, there are variations. You could do this. I don't know if this is what you mean. This first section, you can leave the first section blank, like that, see? And just put your initialization outside the loop. That's okay. You need 3 sections in the for loop. You got to have 2 semicolons in the for loop. In that sense, the form will always be the same. And I think you can do other things in there like that. I'm not sure though. I'm not sure about that one. Anyway, we're not going to look at that. All right. We don't have a lot of time. Let's see. Are there any more problems to do here? You want to do 10? 9? Let's try to do it quickly. Write a program that prompts the user to enter a number between 3 and 13 inclusive. If the user enters a number inside, see that square bracket from math? That means inclusive, good. The problem displays good number if the user enters in a good number, otherwise it says bad number. Okay, so 3 to 12, here we go. I'll say n is the number, and this should be Cn to n. Now we have the if statement. If n is less than 3, or n is greater than 12. Whoop, that's bad. No, this is it's less than 3 or greater than 12. That's bad. In other words, 2. 2 is less than 3. 30 is greater than 12. If it's less than 3, we know it's bad. It's got to be between 3 and 12. If it's less than 3, we don't have to do the rest of it. We know it's bad. And so and this is good. I'm not going to worry about that. If the user enters in a floating point number, 12.7, then it'll stop reading the number at the point. It'll just take a 12. Or it's going to crash. I don't know which one it is. Don't head out too fast. I want to show you a variation that's important to understand. And this is a very important variation. You can do it like this as well. If n is greater than or equal to 3 and n is less than or equal to 12, then it's good. Otherwise, it's bad. This is a very important variation to understand, and you can see this is an AND operation here, and up here we have the OR operation. These two give you the same result, and which one is easier for you to read and understand? For me, that's the same thing. But so you'll see that this kind of problem coded up in those two different ways, and it's arbitrary which way the person's going to code it up. Okay, that's it.